Whoa there. Sorry, my pet medicine alarm went off. So don't worry, both the cat and the dog have had their medicine now, and I'm back to pick up where we started off. So this would just be one last kind of quick example to finish off this, what would have been our first video here, just looking at excluded values from the domain of a rational expression. So I was going to do one last factoring example that was a little bit more involved. So x minus 5 over x squared minus 3x minus 10. So let's find, right, all x values to exclude from our domain. Boy, I think the longer and longer I do these videos, the worse my handwriting gets. I should try to write a little bit cleaner. For you guys next time, I promise to do better. So we're only looking at the denominator. So let's pull this out. This we said is x squared minus 3x minus 10. And then the whole idea, right, just like in the other one, is that is not allowed to equal 0. So, okay, that's great. This one, unlike the one we were doing before, x squared minus 4, we kind of said you could kind of reason out if you added the 4 over here, how you're going to get from x squared to 4, you would need to do a minus or a positive 2, right? That was kind of where we ended up. You could kind of reason that one out. This one, not so much, right? X squared minus 3x minus 10. You have to do some sort of random guess and check method to kind of stumble into whatever your restrictions here would be. Random guess and check is not a very, it's just not really a very sound math strategy. So rather than do that, let's factor like we did before. This one will do the sort of full ABC equals deal, right? A is 1, B is minus 3, C is minus 10. This is the case where A equals 1. So that's great news. That means if we do A times C is negative 10, we need to add to our number in the middle, minus 3. So that means when I find the pair that does that, I can essentially jump right to factoring it based on that pair. What's going to get us there? You know, minus 1 times 10, no. You know, 1 and minus 10, no, that's not going to do it, right? That would be, you know, 9 and negative 9 respectively. So what else? 2s and 5s? 2 and negative 5? Yeah, that'll do it, right? 2 plus negative 5 would be negative 3. So that's my pair. As soon as I hit on the pair that works, I can stop. I don't need to check any more numbers. I just need one that works. So I've got it. So my pair here would be 2 and negative 5. When your A value is 1, right, where it's 1x squared plus minus something times x plus minus some other number, rather than expand it and then do a factoring by grouping, we can instead just jump right to the factored version. So this is going to factor based exclusively on the 2 and the minus 5. So this would become x plus 2 times x minus 5. And the idea is that's not equal to 0. And so just like we did before, when we had x squared minus 4 factored as x minus 2 and x plus 2, we took each of those individually and just sort of solved them equal to 0, or I guess in this case not equal to 0. We'll do the exact same thing here. What marker should we use? Blue, I guess. So this means for us, x plus 2 is not equal to 0. If we subtract 2, that means x cannot equal negative 2. So that's one of our restrictions. This also means for us x minus 5 cannot equal 0. If we add the 5 over, that means x cannot equal positive 5. As a general rule, the higher the degree of your polynomial in the denominator, the more restrictions you will get. So if we look back to the top of this sheet where we just had, right, single x minus 6, we just had one restriction. For x squared minus 4, x squared minus 3x minus 10, both of those had 2 restrictions. That's not always going to be true. Sometimes what you'll get with an x squared type is you could actually get double restrictions, but they're both the same number, in which case then you just have one restriction and that's fine. But in general, you get 2 different solutions and you'll go from there. That's the basics. We're going to dig into, in the next video, simplifying a rational expression, which is kind of the polynomial equivalent of reducing to lowest terms. So that'll be up next.